Now, welcome to the satellite communication course. We'll continue with the intermodulation products topic in the FDMA. Now, here these IM products are generated, and to avoid these IM products, so our amplifier is to be worked in the linear region. So that's why the total input power to the transponder, whatever the input power given to the transponder, is to be limited. Means what we can say means power transmitted by the user. Okay, power transmitted by the user, that will be controlled. That is nothing but a EIRP. We need to control the transmitted power by the user. If the users transmit the power, if it is increase or whatever the condition power level given by to the each and every user, if there is a violation of that particular power transmitter, then that will increase the input and saturation of the amplifier. Okay, now we can consider that. If that input power is increased, then that will be mis- just like this about a graph is saying about that input and output power. If it is to be operate in a linear region, so input power is to be in the linear, so that will get that output power in linear mode. If input power increases, then that will saturate the amplifier. If that amplifier saturates, then it will generate that intermodulation product. Means amplifier will produce the output. That output will be a distorted output. Means there will be a distortion. So that intermodulation of a product, that is a common product occurred in a multiple carrier transmission system, because the device operating in that multiple carrier system, that devices are a non-linear device, and to avoid the saturation, now this is about a saturation point. To avoid this particular saturation, the amplifier is to be operated in the back off mode. Back off mode means what we say here: input back off mode and output back off mode. So to avoid the saturation, the amplifier is to be operate in the back off mode. If means what we can say that output power of the amplifier, that will be limited to the few dB value, that is below the maximum value, means below the particular saturation value. If we reduce the input power, or reduction, if supposed to be we say that a multiple carriers we are getting, and we'll get that a output power, means that your amplifier is to be operate in the back off mode. If the output power of the amplifier is reduced, then what will happen? Then the transmitted signal from this particular transponder, that will result in the reduction in the, what we can say, a carrier to noise ratio at the earth station. Means from the transmitter transponder, if output power is reduced, then at the earth station carrier to noise ratio is reduced. If it is carrier to noise ratio reduced, so then the channel capacity is reduced. So that's why we need to know about what will be the output power, and the earth station carrier to noise ratio is not to be reduced for a given output power. If that carrier to noise ratio is reduced, the channel capacity is reduced. If the channel capacity is reduced means a total available bandwidth, or you can say that whichever the bandwidth available here, that will be reduced, because that will limit the noise. So means we can say that a power limitation that will reduces the usable bandwidth in the FDMA system. Okay, power limitations are there. So earlier we say that when we say that we start with the FDMA system, we say that there is a limitations of the bandwidth and the limitations of the power. So power limitation reduces the usable bandwidth in the FDMA there. So output power of the transponder after that particular back off, that will be divided in the downlink, or you can say that that will be divided to the particular bandwidth there, so that we can calculate that what will be the output power there. So from the transponder to the earth station, or from the earth station to the transponder there, so in that case they have the limitations regarding that power transmission. So we can calculate that how much is the power required from the earth station to the that transponder. When we transmit the power, how much is the power transmission required, or from the transponder to the earth station, how much is the power required, and that will give us the whatever the limitations there. So means whichever the satellite we say that it is to be operate, that satellite is to be have a constant gain from the given input output power. So to avoid this particular intermodulation products, we say that we need to use, or we can say that that amplifier is to be operate in the given out limit linear region. That amplifier is to be operate in the linear region there. Then we consider that, so carriers another component of the FDMA system. So that is about a MCPC and a SCPC. So that is nothing but a carriers in a FDMA system. They are transmitting the signal, or they are a single information channel, or a multiple information channel, or a multiplex signal, single signal or a multiplex signal. If we consider that a FDMA system, if each carrier uses a single signal, and that is known as a single channel per carrier. If the FDMA system uses a single signal, means each carrier carries a single signal, then we can say that is about a single channel per carrier. If it has a multiplex signal. Okay, if it has a multiplex signal, or you can say that a multiple channel per carrier. You can say that multiple channel per carrier. Now there are the two carrier system used in FDMA, that is single channel per carrier or a multiple channel per carrier. With single signal in each carrier or multiplex signal in the carrier. Okay, means carriers have the multiplex signal, or carriers have a single signal. So now we'll learn that one by one a multiple channel, or you can say that multiplex signal in the carrier, that is about the MCPC FDMA system. So now in this case of a MCPC FDMA system, so if you can consider that whether it will carries for the analog system, then for the analog, then it will use FDM FM carrier. If it is used with a, or it can be used for the digital signal, then you can say that it will be a PCM, sorry, PSK, modulated carrier. Now that is for the analog voice channel, or a digital PCM voice coded signal. So generally, a FDMA system, if you see that FDMA system initially when satellite communication started, so in that case, a first access system used in a satellite, it was a FDMA system. This FDMA access system is used initially in a satellite system. So now in this MCPC FDMA system, it has a earth station equipment, and that earth station equipment means we can consider that a terrestrial interface. It has a terrestrial interface here, and for this terrestrial interface, and then we have the, I'll just draw in terms of a number there so that we can easily complete it. One, two, three. Okay, so we can easily complete everything in the given particular page about the IF combiner. Okay, then it is about a RFTX model, and then a antenna. Okay, you can consider that antenna. Okay, so similarly we have the one, two, three, likewise, and then one, two, three. I'll just write what is the meaning of this 1, 2, 3. Okay. Then that is about to the antenna. One means what? It is a PCM oblique TDM FDM. Then second, then it TX transmitter processor. Okay, that is about a baseband processor there. Then 3 is nothing but what? A QPSK FM modulator. Then 4 is about your transmission filter. And this is about a IF combiner. And that is about a RF or RF transmitter switch. And this is about your antenna. Now, similarly, if you consider that a reverse here, input from the antenna, okay, when we have an antenna, then that is about RF receiver now, okay, RF receiver. Then RF receiver, then we have that IF distribution panel, then RF filter, say one, then we have two, three, four. Okay, one, three, four, and after that, one. Okay, like so now this one is nothing but what? We have the receiver filter. This two is nothing but what? We have a QPSK FM demodulator. Then this three is nothing but what? A receiver baseband processor. And this four is nothing but a PCM, TDM, FDM. And then it goes to the terrestrial input. Okay, or interface. This is about a terrestrial interface here. Now this one is a typical Earth station equipment for the FDMA. This is for the uplink equipment. Uplink means for from the terrestrial interface, it will transmit the signal to the antenna to the okay to the antenna to satellite. And this one is about from this one is about from a satellite. Now this is about a transmission system of the Earth system. If you consider that it has the terrestrial interface, then a various equipment, and that various equipments are nothing but if you consider that they have the baseband processing equipment. Okay, so you can say that this is nothing but a PCM, TDM, FDMA, And this one is about a transmitter baseband processor. Then we have a demodulator. We can say that QPSK FM demodulator. And this one is nothing but a transmitter filter. Now, after modulator, we can consider that a filter means after here we can see that a modulator, sorry, here modulator, here it demodulator. Okay, this one transmitter in transmitter it is modulator. For receiver it is a demodulator. Okay. Now, if it is supposed to be analog voice, so then we can consider that it will be of FDM multiplexer and FM modulator. FDM and FM modulator. And if it is a digital voice, then a TDM multiplexer and a QPSK modulator. So now this is about a, according to that, we have a modulator if it is a analog voice or a digital voice. And all these modulators, they are using a combined, or we can say that is about a common IF combiner, and that is to be operating with a specific frequency band. Generally, we can say that that will be operating in a typically of a 70 megahertz, and this particular modulated carriers they are transmitted to a proper frequency in the IF spectrum. Then this particular filter, a band pass channel filters that is used for a spectral shaping, and they have the different center frequencies and the different bandwidth. Then all these particular transmitting carriers they are combined here, and then that IF spectrum then that will raise to the RF uplink frequency, because here we can say that this is about a earth station, then we can will get that a output that will be uplink one. So that's why we need to raise that whatever the IF output comes from this all the channel, and then it will be uplink to the up converter, and then RF signal will transmit it. Before transmission they will be amplified with a power amplifier, and then it will send to the antenna. So now this RF transmitter module, so it has the up converter, it has the local oscillator, it has the power amplifier, and after that up conversion, then it will be amplified and that will transmit it to the antenna there. If there is any changes in the traffic, or we can say that whatever the terrestrial interface there is nothing but a traffic number of users we see. If any change in the traffic, that will alert the bandwidth requirement of this bandpass filter, and then change in the frequency, then that will alert the center frequency of the filters there. And that in the receiver it has a low noise amplifier at the receiver, then a down converter, and then we have the local oscillator here, so that you get that a down converted output that is a part of a RF receiver block. Then down converted signal is then distributed through this IF distribution panel. This is about a IF distribution panel. And then IF distribution panels separate the each carrier because it has a different receive bandpass filter, and that will separate the carrier there. Then after separation of carrier, then they will be transmitted to the demodulator. So various carriers, we say that each carriers have the a different demodulation techniques, whether it is appropriate, means we can say that analog channels or digital channel. So appropriate demodulator is to be used, means we can say that FM demodulator for analog channels and a QPSK demodulator for the digital signal. After demultiplexing of this receiver signal, so then a demultiplexer rule is just like separate the voice channels. So if you consider that in the transponder or in a transmitter here, your station, it has a FM modulator or a QPSK modulator. But in the case of receiver, it has a FM demodulator and a QPSK demodulator. That are used for the separation of the received signal, analog signals or a digital signal. Now here you can consider that a terrestrial interface, multiple signals are transmitted, multiple users are there, means it is a multiplex signal. And then we have a bandpass filter that is to be used in the receiver to limit the noise. Okay, that is about a filter is used to limit the noise, or they will limit the whatever the altered frequency band or a change frequency band of the operation. Because earlier we say that if that power increased here, so then whichever the filters we are using, so the operating bandwidth will be altered or a bandwidth will change. So according to that requirement, so similarly at a receiver, that particular replacement is to be done for the given multiplex channel. So means we can say that if F1 to Fn are the carriers, likewise. So then there will be alteration of this particular carrier, or that particular flexibility is there in the transmitter as well as in the receiver. If an earth station is communicating with a n network, or we can say that n other earth station there, then earth station will transmit the n channels, and then earth station will receive the n channels. If there is a transmission and reception chains of a n channels, if there will be a multiple channels or a multiple system, multiple earth stations are there, so multiple transmit and receiver, multiple receive, that makes it a system costly. So now we'll because it is about a multiple earth stations they are used, because in this FDMA MCPC FDMA system, that input signal is grouped of a multiplex voice channel. If supposed to be, if you consider that we have a input FDM supergroup of a 60 analog voice channel, 60 analog voice channel, or we can say that a 60 digital voice channel. So that is about AFDM supergroup, either 60 analog voice channels or a 60 digital signal. Okay, okay, either. If supposed to be in this particular group, if the some of the channels in these groups are not active, then whichever the bandwidth allocated for a given transponder or for the earth station, that bandwidth will not alter. Means if supposed to be all 60 channels are active, then operating bandwidth will not waste here. If supposed to be 50 channels are operating, means 10 channels are not operating or not active, then what happen? That given bandwidth or given spectrum for this particular transmission will be wasted. I mean, there is a wasted capacity. So that's why that MCPC FDMA system is not effective when that input traffic is low. Okay, what we are saying is about a this one MCPC FDMA system. It is what we can say ineffective. It is ineffective if when we can say that it is ineffective, not effective when if input traffic is low. For the low traffic, this is not a effective system because that if channels are specified or bandwidth is specified for this multiplex signal. If some of the signals are not active, then this system will not be used. So that's why instead of using a MCPC FDMA system, we can use a single channel SCPC FDMA system. Okay, there are the two types MCPC and SCPC. We can use a single channel per carrier FDMA system. Because in Earth station, if the traffic is low, then that spectrum is wasted. Okay, so due to the wastage of a spectrum, so then that that particular capacity given by allotted for this particular communication, it is wasted there. And for a given particular channel, if it is a low traffic, because that earth stations are designed for the multiple F1 to F1 channel. We separate blocks for each voice channel. Okay, separate blocks are given F1 to Fn. So if the traffic is low, so in that case, that all these blocks not is in use. Suppose I am saying that F1 to Fn and n is supposed to be 60, that is about the maximum operating capacity. So instead of that, if it is a n is equal to 30 now, so only that 30 components is in use and 30 components they are not in use. So means we are just using this particular operation or utilization of that particular capacity is not fulfilled by this particular MCPC FDMA system. So that's why, so we can provide another system or another operation that will permit the utilization of that particular channel, and that is nothing but a SCPC system. But if you consider that a bandwidth required for this SCPC system, that bandwidth for each carrier, that will be a narrow. Yes, this is called a single channel per carrier system. The bandwidth for the each carrier, it will be a narrow, and that will be typically of a 22.5 or 45 kilohertz. So means transponder bandwidth is divided into a narrow band of a either 22 or a 45 kilohertz with a separate carrier frequencies, and that will be distributed to the earth station in the network depending upon the whatever the traffic, according to the expected traffic. Means only the active channels or a active carrier will be transmitted. If there is a no voice input, likewise. If there is a supposed to be some channel is no input there, then that particular input is not transmitted, and that's why it reduces that load on the given transponder. If supposed to be we consider that a transponder system from the bandwidth point of view, so 36 megahertz transponder, okay, that is about the transponder bandwidth, that is about a 36 megahertz. Then it can support up to a maximum 800 carriers. But what happened? So that we say that for this particular megahertz of band, 36 megahertz of bandwidth, it will support up to 800 carriers. But the transponder power cannot adequate for this particular 800 carrier. Okay, again that issue comes because the total input power, we can consider that that is to be operating in the linear region. If supposed to be number of carriers increases, then what will happen? That output power is to be total output power required will be large. So if we consider that a transponder of a 36 megahertz, if it can support 800 carriers, but the transponder output power could not support, they are not supporting this particular 800 carrier. If the transponder is able to support supposed to be 800 simultaneous carriers, then what happen? So that all the carriers are not used all the time there, or that all the carriers are not used fully at a given particular time. So that's why, so instead of a 800 carrier, we need to be consider that a 400 carriers to be a transmitted, or at that particular instant, we consider that a minimum carrier. If supposed to be large number of carriers are there, then there will be limitations regarding the power. So that's why this SCPC system is just like a optimal system in terms of a usage of a channel capacity of the transformer. So instead of that SCPC system, if there are the multiple channels or multiple carriers are there, so we can use SCPC system along with some demand assignment equipment system. So that is called as a SCPC PCM multiple access demand assignment equipment, that is called as SPADE system. Yes, for what? A SCPC, okay, PCM multiple access demand assignment, okay, demand assignment equipment, and that is called as a SPADE system. And this SPADE system that is used in the earth station if it has a for low traffic, for low traffic, this SPADE system is used at the, we can say that is about it, the earth station, because it has some demand assignment capability. So that's why that SPADE system that will improve the capacity, it will improve the capacity of the single channel per carrier FDMA system. If the traffic is low, when the traffic is low, then SCPC FDMA system is used. Means we can say that a SPADE system is used in the earth station if it has a low traffic. If it has a low traffic, if the traffic is increases, if the traffic is increases, then the SPADE channels are converted into a single channel per carrier channel by permanently assigning the satellite carrier. Now in this system, in the SPADE system, so we have some assigning the channels there. If it is a low traffic, then we can assign the channel. If it is a large traffic, then we have to consider the SCPC system. So that is about a SPADE system. So we'll just draw a SPADE system here for the transmission. So here a terrestrial interface. Okay, this is about a terrestrial interface. 2-way now.